Most people think energy loss, brain fog, fat gain, and accelerated aging are just getting older. They're not. They're symptoms of a failing power grid. Every cell in your body runs on energy. That energy comes from your mitochondria. And when mitochondria stop working efficiently, everything downstream starts to break. Today, we're going to break this down clearly. What mitochondria actually do. What happens when they fail. The difference between MOTs-C and SS31, and how supporting composins theoretically fit into mitochondrial health. This is educational. This is research-based. And this is about fixing the root cause, not chasing symptoms. Hi, I'm Kirk with the Wellness Elevation channel. So what are mitochondria? Think of mitochondria as power plants, not batteries. Batteries store energy, power plants produce it. Mitochondria take oxygen and nutrients and convert them into ATP, the energy currency that fuels muscle contraction, brain signaling, hormone production, immune function, cellular repair. ATP powers everything. If ATP production drops, your body doesn't slow down politely. It enters survival mode. Repair shuts off. Inflammation turns on. Hormones fall. Fat storage increases, and the body starts borrowing energy instead of producing it efficiently. That's where aging accelerates. Modern life is a perfect storm for mitochondrial damage. Chronic stress floods cells with cortisol. Poor sleep blocks repair cycles. Sedentary behavior reduces mitochondrial biogenesis. Processed foods and seed oils increase oxidative damage. Environmental toxins damage mitochondrial DNA. But three failures dominate everything: excess reactive oxygen species, ROS, chronic inflammation, insulin resistance. These don't happen separately. They form a self-reinforcing loop, and that brings us to the real problem.
Quick pause. If you check the description, you won't see affiliate links, promo codes, or anything I'm trying to sell you. I'm doing this because I genuinely believe people deserve better information about peptides, metabolic health, and longevity. If this content brings you value or helps you think differently about your health, please take a second to subscribe, like the video, share it with someone who needs to hear it, or drop a comment below. It really helps the channel grow, and it lets me keep making more of this content for you. Thank you.
Let's simplify the three-failure cascade. What are reactive oxygen species, ROS? ROS are not evil. They're a byproduct of energy production. But excessive ROS is like sparks flying out of an engine. Those sparks damage mitochondrial membranes, proteins, and DNA. Damaged mitochondria leak more ROS. Now the engine is damaging itself. What is chronic inflammation? Inflammation is supposed to be temporary, but damaged mitochondria constantly trigger immune alarms. This is like a fire alarm that never shuts off. Your immune system stays activated. Tissues never fully repair. Hormonal signaling gets disrupted. Fatigue becomes chronic. So, what is insulin resistance? When cells are inflamed and energy starved, they stop responding to insulin. This is like a rusty lock on the cell's fuel door. Glucose stays in the bloodstream. Fat storage increases. Energy production drops even further. Now the cycle feeds itself. Poor energy equals more ROS-y. More ROS equals more inflammation. More inflammation equals worse insulin resistance. Worse insulin resistance equals even lower ATP. This is the biological foundation of neurodegeneration, metabolic syndrome, cardiovascular disease, hormonal decline, accelerated aging. The problem isn't motivation, it's infrastructure failure. This is where confusion happens online, so let's be precise. The first mitochondrial peptide we talk about is MOTs-C. MOTs-C is a mitochondrial encoded signaling peptide. Think of it as software. It sends a message from mitochondria to the nucleus that says energy demand is high, adapt. MOTs-C activates AMPK, the energy sensor, improves glucose utilization, increases insulin sensitivity, signals mitochondrial biogenesis. It doesn't repair broken machinery. It upgrades the operating system. The second mitochondrial peptide is SS31. SS31 is not a signal. It's a structural repair compound. Think of it as hardware repair. SS31 binds to cardiolipin, a critical lipid in the inner mitochondrial membrane, and stabilizes the electron transport chain. This reduces electron leakage, lowers ROS production, and improves ATP efficiency. SS31 doesn't tell the system what to do. It fixes the damaged wiring. That's the difference. They're not competitors. They're not interchangeable. They solve different problems. So, how else can we add support with additional peptides and compounds? Once you understand signal versus structure, the rest of this makes sense. MOTs-C sends the signal, SS31 protects the structure. But signaling and structure only work if the system has fuel and efficiency. That brings us to NAD+. NAD+ is like payroll for cellular workers. No NAD+, then no repair. No NAD+, then no DNA maintenance. No NAD+, then no mitochondrial adaptation. Supporting NAD+ availability helps both signaling and repair systems actually execute their job. That's where 5-amino-1-MQ comes in. 5-amino-1-MQ targets NNMT, an enzyme that drains NAD+ and promotes metabolic inefficiency. Conceptually, MOTs-C sends the signal. 5-amino-1-MQ removes the metabolic brakes. NAD+ availability improves execution. Now there's one more compound that fits here. Methylene Blue. Methylene Blue doesn't send signals, and it doesn't build mitochondria. It supports electron flow efficiency. Think of the electron transport chain like a power line. When electrons leak or stall, you don't get energy. You get oxidative stress. Methylene Blue acts like a backup conductor, helping electrons move forward instead of creating damage. So in the system, MOTs-C increases capacity, SS31 stabilizes the membrane, NAD+ funds the process, 5-amino-1-MQ removes drag, Methylene Blue improves power delivery, and finally, long-term mitochondrial health depends on turnover. Old, damaged mitochondria must be cleared so new, efficient ones can replace them. That's where mitophagy-supporting compounds come in, not to create energy, but to keep the system clean. This isn't about forcing energy, it's about restoring efficiency, resilience, and output at the cellular level. If you're not a regular on this channel, I usually share my own personal research experience when I have it, and in this case, I do. When I first started my journey into peptide research, I began with retatrutide and MOTs-C. Now, to be clear, I was already doing a lot of things right at that time, eating better, losing weight, exercising, resistance training, all the fundamentals that help anyone feel better. But shortly after starting this research, I noticed something different. I felt a way I honestly hadn't felt in decades. I started retatrutide at a very light dose, consistent with human trial protocols, and titrated up slowly. I approached MOTs-C the same way. Within a few weeks, I introduced Methylene Blue and later began researching 5-amino-1-MQ. Now, to be completely transparent, did I personally notice a clear, identifiable effect from 5-amino-1-MQ? I can't honestly say that I did. That doesn't mean there wasn't a benefit. It means I have no reliable way to isolate or attribute a specific effect. In my research, I ran MOTs-C and 5-amino-1-MQ every other day, 1 milligram of each, subcutaneous, until I completed 2 20-milligram vials. Alongside that, I was running retatrutide, creatine, Methylene Blue, eating an animal-based high-protein diet, prioritizing sleep, exercise, and resistance training. The result? I genuinely felt like a new person. My biomarkers were rapidly improving, and today, I'm no longer insulin resistant. I have not personally researched NAD+ or SS31 yet, but based on what we've discussed in this video, I wouldn't hesitate for a moment to do so. So whether you're looking at this from personal experience, published research, or pure biological logic, it all points to the same conclusion. Mitochondrial health is not a biohack, it's biology. When energy production works, inflammation drops, insulin sensitivity improves, recovery accelerates, aging slows. MOTs-C addresses adaptation and signaling. SS31 addresses structural integrity, and supporting compounds help the system function efficiently. So, stop chasing stimulants, stop masking symptoms, fix the power grid. That's where real performance, health, and longevity begin. If this helped you understand mitochondrial health at a deeper level, not hype, not shortcuts, just signal, structure, and biology, then hit like so this reaches more people who need real information. Subscribe to the channel if you want more deep dive investigations like this, and drop a comment letting me know which compound or pathway you want me to break down next. Because the future of health isn't about chasing symptoms, it's about fixing the power source.